In this video, I want to have a look at how we can calculate the distance between a point and a line. So if we have a straight line and we have a point over here somewhere, if we want to find the distance between this point and that line, there's actually an infinite number of ways we could do that. We could find the distance along here. We could find the distance coming over this way. So there's an infinite number of ways we could do it. The only one that we're going to be interested in though is the shortest distance possible. And the way that happens is if we find the distance that meets this line at right angles. So it meets it there at right angles, and that's going to be the shortest distance possible between the line and the point. So it is called the perpendicular distance. So to calculate the perpendicular distance from a point x1, y1 to a line ax plus by plus c equals 0, we can use the formula that's on your formula sheet, and that formula is the distance is equal to the absolute value of ax1 plus by1 plus c over the square root of a squared plus b squared. So those a's, b's and c's come from the general form of a line, so it's the coefficient of x, coefficient of y and the constant term. And the x1, y1 are the coordinates of the point that we're interested in. So let's have a look at what that looks like with an example. So our first example asks us to find the perpendicular distance between the point 5 minus 2 and a line with equation 3x minus 4y minus 30 equals 0. So the first thing we should always do is write down our formula. So we've got d equals the absolute value of ax1 plus by1 plus c over the square root of a squared plus b squared. So in this question, our 5 is our x1, our minus 2 is our y1, the coefficient of x, so that 3, is our a, the minus 4 is our b, and the minus 30 is our c. So we're going to substitute all of those things in. So we're going to have the absolute value of 3 times 5 plus minus 4 times minus 2. Oops. And then we've got that minus 30 in there as well. So plus minus 30. That's going to be all over the square root of a squared, so 3 squared, plus b squared, which is that minus 4 squared. So simplifying that down, that would give us 3 times 5 is 15, minus 4 times minus 2 is 8, and then we've got our minus 30 on the end there, over the square root of 9 plus 16. Now simplifying that again, 15 plus 8 minus 30 will give us minus 7 over the square root of 25. I've just run out of room, but we'll write it over here. So the absolute value of minus 7 is just going to be 7, and the square root of 25 is 5. So we're going to have the perpendicular distance being 7 over 5 units. Now because that comes out to be a fairly nice non-recurring decimal, we could also write it as 1.4 units long. So one last example, we're asked to find the perpendicular distance between the point minus 1, 8 and the line 2x minus y plus 5 is equal to 0. So I've already written out our formula as our first step. So our minus 1 is going to be our x1, our 8 is our y1, 2 is a, the coefficient of y is minus 1, so that's our b, and our 5 is our constant term, so that's c. So we'll substitute everything in and have the absolute value of 2 times minus 1. And we're going to have plus b y1, so minus 1 times 8. And then plus c, which is our 5. So that's going to be all over the square root of a squared, so 2 squared, plus minus 1 squared. So simplifying that, 2 times minus 1 is minus 2. Minus 1 times 8 is minus 8. And we've got our plus 5 there. And it's going to be over the square root of 4 plus 1. Now minus 2 minus 8 would give us a minus 10. So plus 5, that would give us a minus 5 over the square root of 5. I'm just going to bring that back over up here. So the absolute value of minus 5 is just 5. So we've got 5 over root 5. Now whenever we end up with an answer with a surd in the denominator, we always want to rationalise that denominator because it makes things a lot nicer to work with. So to simplify that, we'd have to multiply the top and the bottom by the square root of 5. So we'd end up with 5 root 5 over, now root 5 times root 5 just gives us 5, and those there are going to simplify, so they're going to cancel through to give 1, and we'll just end up with an answer of root 5 units. So those are a few examples of finding the perpendicular distance between a point and a line.